Okay, so now it's summary time. We just gave you one example showing you that dynamic programming is actually more useful if we are having uncertainty. When there is uncertainty, your deterministic model basically does not work. Your your linear program, integer program, nonlinear programs, those deterministic model cannot deal with uncertainty. Because if you are running a linear program where you see multiple periods, you do all the decisions, all the plannings at the beginning. You plan ahead for every period. You ignore those uncertainty. That's not going to be optimal if you really have uncertainty. Okay? So dynamic programming has a different perspective. Dynamic programming does not plan for all the periods at the beginning. I just want to plan for today. And then I'm going to see what's going to happen. For tomorrow, I'm going to make my decisions tomorrow. After today, the demand is realized. Okay, so dynamic programming helps as we choose an optimal action in each period after all the past uncertainty has been resolved. Okay, we choose an optimal action, again, for any possible situation at any time. Here, what does that mean? All possible situation just means all possible states. We still have that optimality principle. To make an optimal decision, we need to look at the state, but we don't need to look at previous state, and we don't need to look at previous optimal decisions. Okay, in this sense, dynamic programming actually has a tight connection with several new things, and I shouldn't say new things. For example, it's connected to Markov decision process, which is something that is very useful in dynamic control. And it also has a tight connection with reinforced learning, which is a very famous tool in machine learning. Okay, so again, you can see that our OR methodologies can serve for foundations for more advanced techniques. Okay. Also, we can say that in game theory, we also have the place for you to do dynamic programming. What does that mean? Because you may have dynamic games that you do something, I do something, you do something, I do something. Those dynamic games are also solved with backward induction. Of course, in this course, we don't want to talk about game theory, but if you take some game theory course in the future, you definitely will see backward induction again. So that can also be considered as some kind of applications of dynamic programming. So for today, I'm going to stop here, and even though we just gave you some very basic examples, I hope you get some basic ideas about dynamic programming, backward induction, optimality equation, optimality principle, state, decisions, period by period, value to go. Hope that helps.